Lithium-ion batteries are great for storing energy, but over time, as they charge and discharge repeatedly, they slowly lose this ability. However, a new startup called Rondo Energy have secured $22 million in funding for their new superheated storage system, which can charge and discharge for over 100 years without the materials becoming less effective. In this video, we'll see how they've achieved this with 98% storage efficiency at energy densities equal to lithium-ion batteries at 20% of the cost and without using critical materials.
There's nothing that is not available basically on every continent except Antarctica.
This combined means that we can end the need for batteries in large-scale storage where heating is required. Storing energy is quickly becoming one of the most important challenges of the century. The cheapest clean energy sources are unpredictable. Therefore, the energy has to be stored while it's generated so that we can use it when we need it. Lithium-ion batteries are being used for energy storage in people's homes, all the way up to huge ones connected directly to the grid. However, storing energy like this on increasingly large scales is expensive and can have negative environmental impacts. So how is Rondo Energy avoiding this problem? And what makes their system so special that it's got the likes of Bill Gates' clean energy funds interested? Some systems choose to use gravitational energy or mechanical energy, but Rondo is using thermal energy, which is particularly useful if you're planning to heat something. Now, many other thermal storage systems exist, but by the end of this video, you'll see why this is different. The first big issue for most thermal storage systems is that they're too cold for many applications. This problem is actually twofold, because it means they store less energy and they can't deliver heat at the required temperatures. For industrial heat, when working with steel, cement, fertilizers, and ethylene, steam near or above 1,000 degrees Celsius is often needed.
Some of our investors are cement manufacturers precisely because they picked us because this is the pathway for making a big early step reduction at low cost.
Although we don't often think of industrial heat in our day-to-day lives, it makes up a huge percentage of global energy consumption. In fact, 36% of total greenhouse gas emissions come from industrial applications, with 74% of those emissions coming just from heating. Clearly, this is a big problem. And whilst batteries could be used to store electricity that is then later used to heat up steam to the required temperatures, it is almost always too expensive. However, with the Rondo heat battery, cheap renewable energy combined with cheap storage makes this green option cheaper than using natural gas in many global markets. This is a real win-win, especially when you consider that this is a market labelled as hard to decarbonize. Now we know why the Rondo heat battery is so useful, we can look at how it works. Although this system is generally simple to understand, there's some really interesting engineering happening behind the scenes. The overview is that intermittent energy from the grid comes in and powers electrical heaters, which are used to heat the bricks in an echo heating chamber. When the bricks are heated and the system is charged, air can be blown over those bricks and heated up before being used to heat steam in a heat exchanger for continuous use in industrial applications. The great thing is, these are all well-proven technologies from other sectors that Rondo is using in a new and novel way.
To the greatest possible extent, we're not inventing things, right? We're really building on we stand on the shoulders of giants. Our core innovation was the core physics insight, and then the system design and all of it and its applications.
The core innovation that John is talking about is that echo heating chamber I mentioned earlier.
That was the breakthrough that led to being able to build a heat battery that can be super low cost, super efficient, and high enough temperature to deliver about 95% of all the industrial heat that's in use worldwide.
The echo chamber is where the bricks and heater sit, with each of them radiating heat to one another and bouncing around like an echo. And this is what makes the system possible. Most other heat battery systems rely on a fluid like air or water to heat up the storage mass, which may be rocks or sand, for example. However, this requires turbo machinery and causes hotspots within the battery as the heat is slow to conduct through the storage medium. Both of these limit the operational temperature and the rate that you can charge and discharge the system.
One of the things that we see in electricity grids around the world, the faster you can charge, the greater the benefit you can provide to the grid.
The reason the radiation echo chamber works can be seen in the radiation equation. The first three terms are the Stefan-Boltzmann constant, the emissivity of the material, and the surface area. However, what is important is the fact that the temperature variables are put to the fourth power. This means that if the temperature of one brick is even just slightly colder than another brick, there'll be a massive amount of heat transfer to it through radiation, enabling uniform heating and no hotspots. The extremely high temperatures this technology enables also means that the system can have energy densities as high as lithium-ion batteries at around 260 watt-hours per kilogram. But this total energy density can only be achieved by discharging the battery much below the 1000 degrees Celsius output that we need, as the energy stored is proportional to the change in temperature. Therefore, Rondo can use a double stack approach, which means one heat battery can deeply discharge to far below 1000 degrees and be used to preheat the air before going into a second stack and heating to the required temperature for the steam. One thing I was interested in is how this heat battery manages to maintain its heat over up to 12-hour periods when no renewable energy is coming in, as this would require some pretty serious insulation due to the high temperatures. For this reason, Rondo is using dynamic insulation. This works by having a double wall surrounding the heated bricks with an air gap in between them. This is somewhat similar to double glazing, which uses argon gas between the two panels, as argon is very bad at conducting heat. However, what makes Rondo's insulation dynamic is that the air in the air gap flows around the whole system before being directed through the heat battery and over the hot bricks. This means that the final layer of insulation only has to deal with temperatures of around 150 degrees instead of around 1500 inside the actual chamber. Although industrial heat is clearly a big enough sector to tackle on its own, Rondo's heat battery could actually be used in other situations, such as district heating, where thermal energy is stored and delivered to houses on a heating network.
On a cost per stored energy, remarkably, storing heat at over 1,000 in brick and then mixing it down and delivering 120 C heat off that is lower cost than storing heat in a water tank.
Storing heat is clearly an interesting topic, but if you want to learn more about extracting it from the ground, check out this video and like and subscribe to see more videos on clean technology.